Welcome to BKW Physics. We're going to do 3 inertia demos today, and I have 2 volunteers that have agreed for the first one. Now notice I picked these people because we have a smaller person and a much larger person. And the idea of inertia, as you recall, if you haven't learned it, would be that inertia depends on how much mass someone has. Okay? So what I'm going to have these 2 volunteers do is put their hands together in the middle. And at this point, I'm going to ask each person to start pushing a little bit towards each other. Cheyenne, you try to push Joe back as much as you can. She's readjusting her feet. You notice she's really leaning into it at this point. Now, Joe, could you just gently push her off of that? Okay? And that is a perfect example of what I'm saying here. No matter what Cheyenne does, she can't win the inertia battle. Okay? She doesn't have enough of it to beat the inertia guy. Okay? So that's the first demonstration of inertia. Thanks, guys. We're going to move on to another one. The next one, are you able to see the table if I go to here?
Yeah.
Okay. The next one, I have a coffee mug, and I might have to try this a few times to get it right. I have an index card, and I place a coin on top. Okay? And usually when I do this, I flick the cup and hurt my finger. So let's try to do this. Watch the coin. Okay? Did it right on the first try. That was good. What happened? Well, I'll do it one more time in case you didn't catch it the first time. Watch the coin. Okay? When I flick it, the index card takes off. The coin, however, doesn't take off. It doesn't even move. All it does is it seems to sit there as the card leaves and then falls straight down into the cup. How is that an example or a demonstration of inertia? Explain it back to me. Joe, help out.
An object at rest tends to stay at rest.
An object at rest tends to stay at rest. Why did this, like what if I had used something lighter, like a penny? I have a penny. If I used a penny, same demonstration. Now I'm not saying I can't do this, but is it harder or easier for me to do this with a penny?
Harder.
Harder, why? Ooh, it did make it, but notice, did you see what happened there? The penny actually went over and hit the rim of the glass before it fell down. It didn't go straight down. What's the difference? Yeah. And we want to refer to it from this point on as inertia. This has less inertia, therefore it didn't have as much ability to stay still, so it almost flew out. But it had just enough and it fell down in, whereas the nickel had more inertia, more mass, and was able to just stay still. And even though, because these 2 things have kind of some friction against one another, even though they have the friction, the inertia must have overpowered the friction in this case, and so the coin stays still and falls down into the container. Now, the last demo, we got to save it up for the last demo. Is this a good spot for me?
Yeah.
Okay. So I have a tablecloth here, high quality. It's not really a tablecloth, but it's just a piece of material. Okay? So we're gonna do a demonstration here, which is the same concept. And you can tell me why in a second, so just watch it. I have to get properly excited to do this. Okay? And if I do it in the right manner, nothing flies towards me. Okay? So, watch again. Alright. How is this demonstrating inertia again? Well, the same as the coin with the index card. Objects that are at rest want to stay at rest. That's inertia. And the more inertia you have, the more they want to stay at rest. So which is easier, doing it the way I just did it, or doing it this way? This is easier, watch. I don't even have to try that hard, I can pull it right out, because as I add more and more inertia, this wants to stay still more and more, and the demonstration becomes easier and easier. So, for the final challenge, not that you haven't seen this before, but it's still kind of fun. We put 3 things. If they hit into me, don't worry, it won't kill me. Okay, once in a while I mess this up. But you gotta go kind of fast. The other thing is, this one's heavy, but it's got a small surface area, and that tends to make it want to go and start tumbling and catch on the tablecloth and whatnot. So here we go. This is tough for a Monday morning, Tuesday. Okay, whew, that almost came. Okay, but you can see that an object at rest wants to stay at rest. Physics.